Now look at this a problem. Today we are going to discuss how to solve this LPP by simplex method. The same problem was solved by graphical method in another video. In this video we are using simplex method. So this is objective function. These two are constraints. Now the first step is standard form. The first step is what? Standard form. Standard form means what? Look at this constraints. By adding some value here, so-called slack variable, we can make this equal to, okay? So that slack variable I am adding with this and equal to 1 I am writing. So that is possible here. This S1 we call it as a slack variable. Now come to the second constraint again. Here again less than or equal to comes here. By adding some variable this side, it is possible to make this into equal. So a second slack variable adding with this to get this inequation into equation. So that way I am getting the second equation, x2 plus x3 plus s2 equals 4. Right. Now what I am doing there, this what variable I have added with the 0 as the coefficients, 0 into s1 and 0 into s2, I am adding with the objective function. So mathematically the objective function will not be altered when I add these two variables s1 s2 with the coefficients 0. So this particular form we call it that standard form. Okay, standard form. I'm repeating again. By adding one slack variable with this, by adding another slack variable with this, it is possible to make these two inequations into equations like this. Okay, by adding these two slack variables. Now note that x1, x2, s1, s2 all are greater than or equal to 0. That's what you have to understand. All variables, decision variables are positive. And thus the first step is over. Now how to get the second step? Second step we call it as modified form. This is nothing but the variables on the one side and constant on the other side. That's called we call it as modified form. So here the variable, you bring all these things this side, you will get this. You all bring this side, what will have 2x1 minus 2x1, bring this side minus 3x2, bring this side minus 0s1, bring this that side minus 0s2, and plus z equals 0. So bring all these variables this side, you will get these particular equations. So second equations I am writing with x1 plus x2 plus s1, but s2 is not coming, therefore I can write it as plus 0 into s2, and z is not coming in this particular equation, therefore I am taking plus 0 into z. Then the right hand side we have 1. Similarly here I can write here some wrong is going on, I think so. Am I correct? The thing is that here you must note that here is not now here actually it is what you have to understand that here it is x1 and here it is x2. That's what you have to understand here. Okay, so x1 plus x2 plus s1 is equal to 1 here. The actually here x1 plus x2 plus s2 is equal to 4. So we get 3 into x1. Actually here this must be 3. Okay, 3 into x1 plus x2 plus 0 into s1 plus s2 plus 0 is that equals 4. Here we are writing this equation such that it contains all the variable. Okay, so 3x1 is there, x2 is there, but s1 is not there, so plus 0 into s1 plus next one is s2 I am writing as z is not there, plus 0 into z equals 4. Okay, so this form such that uh, the variables on the left hand side and constant on the right hand side is called a modified form. We call it as a modified form. Okay, modified form. Right. Now the next step is about simplex table. Okay, so simplex table is nothing but, first of all, we are writing the variable at the top: x1, x2, s1, s2, z constant variable and basic variable. Okay, so x1, x2, x1, x2, s1, s2, z constant basic variable. So at the top you write all those variables. Then the coefficient you are writing here, the coefficient of the first equations. Okay, the first equation coefficient is x1, you write minus 2, you write minus 2. The coefficient of x2 is minus 3, minus 3. Coefficient of s1 is 0, 0. Coefficient of s2 is 0, 0. And coefficient of z is 1, 1. And constant is 0, 0. The basic variable I will tell you later. Now second equation, coefficient of x1 is 1. Coefficient of x2 is 1. Coefficient of s1 is 0. Coefficient of s2 is 0. And coefficient of z is what? 0. And coefficient of constant is 1. And last one is, I tell you how this comes. Now last one, the coefficient of x1 is 3, the coefficient of x2 is 1, the coefficient of s1 is 0, the coefficient of s2 is 1, coefficient of z is 0, and the constant is 4. All these things we have to fill up. Now after filling up this, so some variables are in the canonical form. This is in canonical form, this is in canonical form, and this is in canonical form. So with this you write z is in canonical form, and here what is s1? S1 is in canonical form. Then s2 is in canonical form. This is what? S2. Okay, so 1, 2, 3, these two are in canonical form. One is coming here straight to that, z is coming there, that is z you are writing here, and then coming here, so straight to this, what is s1 is there, that s1 you are writing there, and then s2 is here, and last one is there, you are writing s2 here. And thus we can write z s1 s2. Okay, so now this is called a simplex table. The next step is about optimum check, whether optimum is reached or not. That's what. So for this you are looking the z row. The z row, if you have any minus number, then it implies optimum is not reached, because our aim is maximize z. Our aim is maximize z. So whenever the negative number comes here, then the optimum will not be reached. The optimum will not be reached. Okay, that's what you have to understand. Optimum will not be reached. So minus negative number exists, therefore optimum is not reached, therefore the optimum is not reached. So thus the optimum checkup is over. Now coming to step number 5, we have to find the minimum replacement ratio, that is Ci by Xi. Constant is this, okay, Xi is this. We have to find the ratio of this number divided by this number divided by this number. Among them, which is the minimum that we have to take? 1 by 1, that is what here, and 4 by 1, we have 1 here. Okay, 1 by 1 we have here, 4 by 1 we have here. So minimum is what? 1. Minimum is 1. So this is what the minimum ratio is, this divided by this. So this is the maximum negative number, which is called the incoming variable. Okay, so this is the incoming variable, and the intersection of the incoming variable and outgoing variable. Okay, outgoing variable, we have found this as s1, and this number we call it as the pivotal element. So intersection of outgoing variable and incoming variable. Here the outgoing variable is S1. Outgoing variable is what? S1. Incoming variable is x2. That means x2 is going to come in the basic variable and x2 is going out of the basic variable. So that's what we have to understand. Now look at this. This is 1. Pivotal element is 1 here. Okay. Now by using this pivotal element, we have to make this 0. That is the next step that we have to understand. So in this particular table, how this particular table comes, simplex table 2 comes. You listen here. We have to make by using this element, or by using this pivotal element, we have to make it here 0. So what you do, you multiply equation number 2 by 3, add with this. You will get 0 here. Am I correct? Similarly, you multiply this by 3, add with this. 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 Multiply by this 3, add with this. So that is what the first step we have here. Multiply this by 3, add with this. You will get 1. Multiply this by 3, add with this, you will get 3. Multiply this by 3, add with this, you will get 3. Like that, a new equations we are getting, that is equation number 4. Now again, here we have to get 0. Here we have to get 0. Our aim is that to bring this in a canonical form. So this we have to make it 0 by using this particular pivotal element. So multiply this by -1. Add with this, you will get 0 here. So that operation, that is multiplying by -1, add with this, you do all the elements in this particular equations. That is equation number 2. Second equation you write as it is. Now the third equation we have to make it here 0. So multiply equation number 3 by -1. Multiply the equation number actually multiply equation number 2 by -1, multiply 2 by -1 and add with 3. Add with 3 here. It is 3. Okay. Here it is 3. Add with this 3. Okay. So what we'll get? -1 plus 1 0, -1 plus 3 2, -1 plus 0 -1, like that you will get here. -1 plus 4, 3 you will get. Okay, so this is what simplex table 2, the second simplex table we have got here. Now after doing this particular operation, we have to find out the optimum check again. So immediately after the simplex table, we have to come to the optimum check. Optimum check means we are seeing the Z row. If all the Z rows have the positive number, then we have reached our optimum, that is maximum. If some negative number comes here, optimum is not reached. So here optimum check we are doing there, and if we see that all the elements on the Z row are positive number, positive, that implies there is no negative number. That implies the optimum is reached. Okay, so we have to see that the Z row. The Z row all are positive implies maximum is reached. Therefore, our solution set is from here we have to come here. This is basic solve. X2 is equal to 1, x2 is equal to 3. But x1 is not coming here. Therefore, that becomes 0. So, whenever x1 coming, x1 and x2 coming here, that value we have to take. But actually, x1 is not coming here as a basic variable. Therefore, that value is 0, and x2, from this table we see that x2 is equal to 1. So substituting this in the maximum Z, we will get 2 into 0 plus 3 into 1, that becomes 3. So thus we can solve the by simplex method. Okay, you put or you play this video again and again, and at last you will understand that. One times or two times seeing this video never gives you some ideas. So play it again and again, at last you will get the answer. Okay, we will come to the another video at that time. Thank you.